again to the channel. It's Oluwa shown here. Now, today we want to look at, Dockerfile in depth. And we want to look at, some other keywords, all right, in Dockerfile, some that we have used, some that we have not used, to basically help us understand, some of the keywords, what they mean, when to use which one. And just to give you an understanding of what, the keywords that you see in a Dockerfile basically, all right, represent. And in addition to that, we are also going to be looking at what you call a multi-stage Dockerfile, right? Why do we need a multi-stage Dockerfile? Is it applicable, to every application that we're trying to build an image for? Or can we just use a single stage Dockerfile for, most of the project? We're going to look at the difference and the benefit of having a multi-stage Dockerfile. Is that okay? But then we're going to start with, some of the instructions that you can see right here. So here's the Dockerfile reference on Docker Hub. All right. And of course, you can see some instructions. All right. Now, some of these instructions, we have seen them. All right. We've used quite a number of them, like copy, like from, like expose. We've seen that, like CMD. We've seen that. But of course, there are some other ones that we have not seen. And if you have, maybe by any chance, you've gone through the GitLab CICD series, you must have also seen that, in that series also, we used some of these instructions. For example, the env that you see here, we used it, all right, in the GitLab CICD, all right, series. So let's take a look at, these instructions that we have here and just help us understand, what it is, all right? Now here, the first one you have here is hard. Now, the description here says hard local or remote files and directories. Now, this add instruction is similar to the copy instruction, because what the copy instruction also does is that it copies files and directories, okay? But the difference between the add instruction and the copy instruction is that with the add instruction, you can actually, if you have, let's say you have a zip file or a tar file, and then you want to copy that, into your image file system, right? Now, you don't want to copy the old tar folder. You want to basically copy the content of the tar folder into your image file system. Now, the copy command cannot do that for you, because what the copy command will do is to copy that tar file or the zip file the way it is and drop it in your image file system. But with the hard instruction, you can actually extract, all right, the content of that zip file and then copy the content into your image file system. So that's the difference between the two. That's number one. Now, another thing that hard can also help you to do is that perhaps you want to, download something from the internet, right? You can use the hard instruction to do that, right? More like your call or wget that you use on Linux, all right? You can also use the hard command to fetch something from a remote repository and copy the content of that thing into your image, all right, file system. So the hard can also help us to do that. But the copy will only copy something from your system into the image file system and nothing more, right? Now here you have the ARG, which is used for build time variable. All right, so if you click on any of them, you can click on any of these and look at instruction, all right, further. So for example, this ARG, it says instructions defined, all right, the ARG instruction defines a variable that user can pass at build time to the builder, okay, with the Docker build command. So when you're running any Docker build command, and then perhaps there's a variable that you want to pass into that image that you're building at build time, all right, you can use the ARG, all right, to do that, okay? So basically, you can look at that like, there are variables that you want to pass in. So maybe you define some variables inside of that Docker file, but then you want to pass in the value, okay, while you're building that image, okay, you can do that at build time. So that's what the ARG is used for. The CMD, we've looked at that, which is specified default commands. So for example, in some of the Docker files that we've looked at, all right, we already saw the all right, CMD. So if you look at the one here, this one is Apache, all right, to foreground. And this is the one that we used, all right, before, which is this one, which is node, all right, app.js. So basically what the CMD will do is to specify the command you want to execute the moment you run and that image as a container, right? That's what a CMD is. So basically, this is the default command that should be executed the moment this image is run as a container. All right. So I've talked about the copy command already. Now, entry point here says specify default executable. Now, there's entry point and there's CMD, and sometimes these instructions seem to overlap, right? But like we have seen, you can only have one CMD in a Docker file. All right. But then entry point is also used to execute, commands and, some other things, right? But where can we use entry point? Now, there are certain images that they have, default commands that they would run the moment you execute those images as a container. But sometimes you want to override, that default command. All right. And then the way you override it sometimes is by specifying an entry point. I mean, if you look at the word entry point, basically means, this is what I want you to start with. Okay. By the time you run this image as a container, right? So basically you can use the entry point to override the default command specified by CMD. And one good use case for that is what we have here. Now, if you look at this Jenkins file, we're still going to talk about Jenkins in later video, but I just want to explain to us what this entry point is. Now, if you look at this Jenkins file, now this is an image that I am using. Okay, I'm using an Amazon CLI image to actually perform something at this particular stage. All right, now this particular image has a default executable. But that is not what I want, right? I want to be able to pass in my own commands, right? I don't want to use the default, command that has been specified in this particular image. So I want to run my own commands. So how do I do that? If you look at what I have here, I specified what? Entry point, and I put in, an apostrophe, right? Double one. So the double apostrophe that you see here basically will mean, it should be empty, which means I want to be allowed, or I want the image to allow me to pass in my own commands, which means I am overriding whatever defaults that has been specified in that image. I'm overriding that with what I want to execute. All right. So that is one good use case for entry point. Okay, so which means this particular image, whatever has been specified as the default executable or as the default command, should not run. It should take my own input, and that is what, should be run. Okay, so that is what entry point can help us to achieve in that regard. Now, the env, it's basically used to set environment variables. Like I said, the GitLab CICD series, you can set environment variable within your Dockerfile, okay, that you want to use. Perhaps, maybe your SQL username, SQL password, all those kind of things can be set up as an environment variable, okay? Now, we have also looked at the expose keyword, which says, describe which port your application is listening on. We've seen that even in the last, the last demo that we did, right? So here we says expose 30,000. So basically that expose keyword is going to specify the container port. All right. So that means the container is going to listen on that port. All right. So that's what the expose keyword is for. You have the from, which is used to specify the base image that we want to use to build, our image. And then you have lcheck, which is to check your container. Else on startup. You can use these as well. Okay. So if you click on it further, it gives you an idea of how to use it and what really, this particular instruction does. And then you have label. So label is basically to add the metadata, to your image. So for example, I can come here to my own image right here. I can come here now and I can just say, label. All right. So I can say label. So the key is what? So the key can be, let's say name. All right, and then the value can be shown. Okay, so it's a key value pair thing, right? So just basically a metadata, right? So key value pair. So it can be version, it can be anything really. Okay, it's just a way to describe your image and to give your image some kind of meaning. All right. Then you have the maintainer. So maintainer is to specify the author of an image. So it's similar to image, it's similar to label, but of course it's a more way to say, this is the person maintaining, this particular, Docker image. So you find that in, if you go to Docker Hub, for example, you will find that, in most of the official image that we use, all right, if you look at the Docker file that produced that image, you often find label, you often find maintainer to tell you who is responsible, all right, for that particular image, all right? And then you have some other ones here. You have on build, specify instruction for when the image is used in a build, all right? So you can, you can click on any of these things and just understand them further, but I just want to focus on the ones that are really used, in day to day. Then you have the run, so which is execute to build commands, right? So if you look at this file, we really don't have a run. We only have one here, which is run npm install. And I explained that to us in the last video, that the function of the run is to basically help you to install things. When you want to execute a command, when you want to install any kind of package inside of your image, all those kind of things, you specify it with the run command, all right? Now the shell also set the default shell of an image, stop signal, specify the system call signal, and then you have the user. We talked about this in the earlier videos where we talked about the fact that you can specify a user that you can use to execute, all right, a particular command within your image. And of course, you have volumes. That was like the last video that we did. We talked about volumes. We talked about the importance of volume, that it helps us to ensure persistence and all of that. So you can also specify volume inside of your Dockerfile, right? So it doesn't have to be on a Docker run command alone. Inside of your Dockerfile, you can also specify volume and specify your mount. And if you click on it, all right, you will also see example on how to use volumes. Is that okay? So this is an example right here. Okay. Now we have your work directory, which is change working directory. So work directory, basically, like I explained to us, is to say that, this is the working directory, which means any other, instruction after the work directory, whatever command, whatever it is that you're doing after the work directory instruction, everything is going to be executed inside that particular path that you're specified as your work directory. So that is what the work directory basically is for. All right. So I believe with this explanation now you, have an understanding of the different instructions that you have, all right, in a Dockerfile, what it is. And of course, like I've told us, you can click on any of this instruction and basically understand better how to reference it, how to use it, and all of that. Okay. Now, the next one that I want us to look at very quickly is the concept of multi-stage build. Okay. Now, if you look at this particular Dockerfile that I have here, this Dockerfile is something that you refer to as a single stage, all right, Dockerfile. Now, how do I know that is a single stage? And of course, what makes a Dockerfile a multi-stage Dockerfile, right? Now, the simple definition for that, or the simple answer to that, is the fact that in this Dockerfile, I only have one from, all right, instruction. Okay, so if you look at this thing here, I only have just what? One from, all right, instruction. Let me just remove this. All right, the only from instruction that I have is just one. Okay, now a multi-stage Dockerfile, we have more than one from instruction. Okay, now let's talk about where do we need a single stage and where do we need a multi-stage. Now, like I said, a single stage Dockerfile has only one from instruction. So here I have from node 22 alpha. And then if you look at this file, I don't have any from specified anywhere. Okay. Now, one of the things that the multi-stage does for us is, number one, it helps us to reduce the image size. Now, there are applications that have large dependencies, right, that they have to install in order for that application to function. For example, when you're dealing with Java, all right, you have your Maven build, okay, you want to use, you have your pom.xml, and in the pom.xml, you have specified different dependencies that your application will require. And some applications have such huge dependencies that has to be downloaded. And these dependencies sometimes, they have some caches, they have some things that after it's been installed, you don't need them anymore. And sometimes those things also are bundled, all right, with your application, which can increase the attack surface, inflate the image size and things like that. So what a multi-stage Dockerfile would do for us is that you have a stage, all right, that helps with the build. You have another stage that basically is to execute the application that you have built. Now, for example, when you're dealing with Java, all right, now Java applications produces what you call an executable file or a byte code or something like that, right, in the form of a WAR file or a jar file. right? Now you can have a stage that helps you to build that application and produces a WAR file or a jar file. You can take that jar file, all right, and then you have another stage that basically executes that particular jar file. So which means all the dependencies, all the things that have been downloaded, that has been used to produce, all right, that jar or that WAR file, you really don't need all those things anymore because, I mean, the package that you need has been produced already, right? So in order to reduce the image size, in order to reduce the attack surface, what you would do is to copy, all right, the jar file and then run it, okay, in another stage. So that means that stage that is now running your application does not contain any of the dependencies, all right, that was used to produce that executable file. Is that okay? So that way the attack surface reduces. By the time you're running that image as a container, all right, I mean, you don't have unnecessary dependencies and unnecessary folders, all right, in your runtime environment. Okay, so that is one of the importance of a multi-stage build. All right, so number one, multi-stage build will help you to reduce, all right, your image size as much as possible. Number two, it helps to, take away all the dependencies folders that you don't need in the runtime. All right. And of course, number three, it helps to reduce the attack surface. And of course, at the end of the day, your runtime environment is lighter and only contains the things that you need. All right. That is the importance of a multi-stage build. Okay. So now let's do some practical, right? So here we have a single stage Dockerfile. Like I said, a single stage Dockerfile is basically a Dockerfile that contains a single from keyword or single from instruction. Okay, so now if I come here and I try to build an image from this, right? So if I come here and I say, Docker build -t. So let's say node, all right, single stage, all right, and then let's build this, right? Now that was quick. So if I come here and I say Docker images, all right, I can see here that this node single stage, all right, comes to 183 MB. Is that okay? Now, let's take an example of a multi-stage build. Let me show you what a multi-stage build looks like. So here I have a Docker multi-stage. So if I click on this Docker file right here, now look at what you have. It says from node 22 Alpine as what? As build. So which means this particular stage, I'm using this stage as what? As a build stage. Now, let me say something here. If you look at the Dockerfile instructions, you will realize that these instructions are in the uppercase, right? Your from is in uppercase, your work directory is in uppercase, your copy is in uppercase, your run is in uppercase. I mean, everything you can see here is in what? In uppercase. Now, when you are doing a multi-stage build, now this keyword is basically what I can refer to as, all right, at a label for this particular stage, which means I'm saying that this particular, all right, stage here should be referred to as what? As a build stage. Now, this build is not, all right, it's a standard name, which means it can be anything, right? I can call it builder. I can call it, all right, first stage. I can call it any name that I so wish, all right? But it is not a standard name, okay? But if you look at what you have here, the from here is capital, and the as is also what? Is capital, all right? And those are actually standards, okay? They are standard that you have to adhere to, okay? So now I'm saying that this particular line is what? Is to be referred to as what? As build. Which means what I want to do with this first stage is that I want to build my application first of all. Okay. And now if you look at what you have, I mean, the instruction basically is the same, right? Until you get to the second stage. Now the second stage has another from. Now in Dockerfile, the only instruction that can only, the only instruction that you can only have just one of it is the CMD. All right, is the CMD, but every other instruction you can, have them in multiple lines and all of that, right? So I'm saying that this particular first stage is what is as build. So that's the name that I choose to give to it, right? Now, if I come to the second stage, I say that stage is what is my runtime stage. And I'm basically using the same image as well, right? But in some cases, you can use maybe a very large image, right, at the beginning, and then you can use a slimmer image for your runtime stage. It depends on what you want to do or achieve at the end of the day, right? Now here, I'm saying from node 22 Alpine, that's the second stage, and that's the image that I've chosen to use in the second stage. Now, this second stage, I'm setting the work directory again, and now I have this instruction. So if you look at what you have, it says copy from build. So what am I saying? I'm saying that I'm copying from this particular stage, all right, this particular directory, and I'm copying that into, all right, this is my own work directory, which means everything that I have built inside of this directory, I want to make sure that the same thing is available in this particular directory. All right, since that is the directory where my application is going to run from. Is that okay? And then the second stage is where I now have my what? My expose. And then the second stage is also where I have my what? My CMD. Okay, so the idea is that the first stage should be the build stage. So all the dependencies and every other thing, should happen at that stage, right? The second stage is going to be my runtime stage. So I don't want the dependencies folder. I don't want the cache. I don't want, unnecessary files, all right, in the runtime stage. So the first stage will do all the builds and everything that needs to be downloaded to build my application. And then the second stage is going to be what? My runtime stage. Okay, so now if I come here and I try to build, all right, if I come here now and I try to build this multi-stage, so let's see what happens. So I'm going to cd into that directory, and that directory is Docker, all right, multi-stage. And now I can say Docker build -t, so I can say node colon multi-stage dot, right? So let's build that and let's see, all right, what the difference is going to be. Okay, so now if I do Docker images, all right, now look at what you have for the single stage. All right, so for the single stage, we have the size to be what? 183 MB. For the multi-stage, we have what? 168 MB. Now you can see a reduction in the image size, and that is one of the things that, the multi-stage Dockerfile does for us. So the image size even reduced further. All right. So all the things that actually inflated this particular image size are not present in this one. So there are certain things that, they are just at the build level. I don't need them in my runtime stage. Okay. So the only thing that I need in my runtime stage are the things that I have copied. So that had reduced my image size even further. All right. So that is, what a multi-stage build is and what a single stage, all right, is. So like I said, the single stage is, when you don't have, when you just want to, for example, this one is a 3 MB. It's not as huge as that, all right, it's not as heavy, all right, as, for example, the mini QB that we have here, which is about 1.28 gig. Okay, so we can still say, well, let's run that. But of course, in a production environment, you want to reduce your image size as much as possible. You want to reduce the attack surface as much as possible. You don't want any unnecessary cache folder, any unnecessary dependency folder or files within, all right, your, production environment. So what you do is to reduce the image size as much as possible and only, all right, copy the things that you need in your runtime environment. And that's the only thing you want to copy. All right, you don't want to copy anything that is not necessary. Okay, so that is the difference between the single stage and the multi-stage or a build. So I hope you've learned something in this video. All right, and then thank you so much. I'll see you on the next one.